Okay. All right. Thanks, Andrew. Thank you, everyone, for being here. This is a great crowd. I think when Andrew and I talked about this session, we were at another conference. I think we were at the Joint Conference back in New York about 5 months ago, and he was saying they were really excited to be putting on this Container Days. And one of the challenges every year was this question of where to start. The audience is so broad. Some people are already masters of Kubernetes. Other people are just getting started with Docker. Where do you sort of target the content to make it interesting for everyone who's attending? And so we were talking, one of the ideas we had was to develop a kind of a story that incorporated a bunch of demos, a bunch of live stuff, and just walked through kind of the entire life cycle of a deployment and the life cycle of an application. But before I get started, I think maybe for the whole conference, it'll be really useful to get a couple shows of hands. So just really quickly, if we're just I'm gonna have 3 buckets to put yourself into. Like brand new, this is all, you're just coming here to learn about containers for the first time. That's bucket 1. Bucket 2, I've tried this stuff out on my laptop, I'm getting it going. Maybe I've got Docker Swarm spun up, kind of getting comfortable. Bucket 3, I am an expert, I've got this nailed, I'm running an app in production, I'm here to help other people and see the latest and greatest. So think about it for a second. For hands, show of hands, who's in bucket 1? Who's here really just getting their feet wet for the first time on containers? All right, about maybe 15%. All right, bucket 2, comfortable, know what this stuff is, but I want to get deeper. All right, there's the 60%, 65%. Bucket 3, we're the pros. Look around, people. These are your friends. These are the people you should be finding to ask suggestions from, to figure out what we should do for open sessions to make this a really useful conference. So with that, can you hit the slides for me? Sorry. Okay, so I'm Shannon. This is Bill. I'm one of the founders at Rancher Labs. Bill's pretty much one of the founders of Rancher Labs. He was, I think, our first employee. We are a software company that builds technology around containers. It's all open source. We have a little booth. We're not going to talk about Rancher very much today, so come by our booth if you want to hear about that. This is mostly going to be talking about the ecosystem. We do, every month at Rancher, we do this open source meetup online. It's available to everybody. There's usually 300, 400 people that come in every month, and they tend to go for hours, like 2.5 hours online. People from all over the world dial in to talk about different container topics. And when we were thinking about how to do this session, we thought it might be useful to kind of mimic what we do there, which is typically set up with a good agenda to start with, go through it, and go through a couple slides, then switch to a demo and try to show something and get some feedback, then switch back, go through a couple more slides, get into a demo. And we're going to kind of go through those 3 buckets. First bucket is what we call a dev and a dream. We're just starting out. Containers look cool. We're going to use it on the laptop. But very quickly, almost everybody goes from, oh, this is so great on a laptop. Why not move it to servers? And there's a big jump there in terms of technology you need to understand, things you want to cover. So we'll go through that. We'll talk about the developer building out, and what happens there. We're also going to highlight a lot of sessions that are coming up today. So as the first talk, we thought it'd be useful just to kind of point to other sessions that are going to deep dive on topics that we're going to, by necessity, skim over pretty quickly. So we're going to talk about some of these things, and then we'll go through and look. If I move this over here, when I look to my left, you'll actually still be able to hear me. Because every time I look over here, nobody can hear me. Okay, so there we go. After that, we're going to dive into more of actually running kind of dealing with the issues you deal with when you start to scale, which means logging, monitoring, clustering, networking, load balancing, orchestration, all of the complexity that pretty quickly becomes the challenge of a DevOps team's deploying on containers. So we'll spend a little more time there. And then at the very end, if we have time, we'll dive into a whole nother level of complexity when you kind of start to run this, you're looking at it, and you start to run into issues still. Orchestration only gets you so far. Your logging, your monitoring systems get you so far. And now you're looking at deploying more complex clusters, things that require secret management, things that require configuration injection, things that require you to, think a little bit more outside of the box. We're not just deploying standard, simple systems, maybe persistent storage. A lot of big topics that individually could be whole sessions. We're going to kind of cover those quickly and dive into it. But this is our goal. Think of it as starting through the entire software development pipeline. We're going to go through it. We're going to hit these topics pretty quickly, and then we're going to demo as we go. So the first place that almost every user we've run into over the last 2 years of building software starts is on a laptop. And that's probably the reason I think Docker is so popular. I think at the core, so many technologies that have been developed in the meantime between VMware and Docker, haven't really taken off. And then Docker sort of explodes onto the scene because it's so easy to use on your laptop. If you haven't got Docker running locally, or if you haven't tried out Docker for Mac or Docker for Windows, you really should. It's an amazing tool to use locally for any development work, any testing work you're doing. You can really replicate almost anything on a single machine now with containers. And so there's a session this afternoon, if you forward this, at 11 o'clock coming up where Borja's going to talk about Docker for the developer. And he's going to go into a lot of this in depth about running Docker on your laptop, using the new Docker for Windows, Docker for Map tools. Definitely recommend this. If you're especially in that first group and you're just thinking about how to get started with Docker, how to start using it locally, this is where it starts. But very often, if you go to the next one, the next step for a user is, okay, I need to get the code from my laptop onto the servers. And this is where, pretty quickly, you start to run into building up some of your initial infrastructure to support your Docker deployment. And for a lot of companies to begin with, it's not starting with a big orchestration platform. It's not starting with something like Kubernetes or starting with something like Mesos. You're really starting with probably an existing CI/CD tool, some type of code repository, GitHub, and introducing, for the first time, maybe something like Docker Hub, a registry where you're going to compile your code, push out these immutable objects that are such a component of what we're developing applications around. So whether that's Quay or Nexus or Artifactory or Docker Hub or Amazon or Google or Azure's container registries, there's dozens to pick up from out there. There's lots that are open source. There's really good choices across the board. But you're probably going to want to start centralizing these functions as you build your application. And in the beginning, what we almost always see is the first deployments aren't really orchestrated. A lot of times there's no application blueprints, no replication controllers or Docker Compose files. It's just a bunch of containers getting launched on a host. So we're going to go through that and sort of talk through that experience of just bringing up your first application, deploying it through a CI/CD, some type of source control process. So Bill's going to go through that now. So in this first demo, we're just going to bring up a simple, I think it's a Python application running on Postgres, but we're going to show how Git, Jenkins, and Docker Hub kind of work together to allow you to take some piece of code and push it out in containers onto a server.
Can you hear me?
Yes.
Great. Cool. So the fun thing about this format is you get to see how much good karma we've accumulated over time for demos. So what we're going to show right now is basically just a small Python app that is the orchestrating Docker app. It's their demo as well. But it's bigger. Oh, yes. Sorry, I haven't got there yet. Better?
Much.
Cool. And so what we're going to be looking at is just kind of your standard 3-tier app. It's got a load balancer, some Nginx containers, and a Postgres. It just is a little hello world. It says my company message board. We can say, hi, ContainerDays. And it'll stay. So if everything goes right, we're going to make a small change because, as good developers, we've got a CI pipe process already. We build our code and test it and publish our stuff from a CI pipeline. So let's just make a small change. We've got our Flask on Docker. Say we don't really like the my company message board. We'll just change that. And we'll say, instead of my, we'll say Acme company message board. Company. And we'll just push to master because that's what we do. All right, and if things go well, you can see the stages of the pipeline kicking off. So your first step is, you build your code, you run your tests, and then that went well. Then we go and we publish our artifacts to a registry. Yes, we do. So it just takes it and pushes it up there. And so really this is just kind of your basic, pipeline, only now with containers. You're, instead of building a binary and just shipping that to some artifact repository, you're building a whole container and you're pushing that up, and that's going and going and good. And then now you deploy it because you kind of have your CD pipeline. You've integrated it to something you've already got existing, whether it's like your Ansible process, it's logging in with SSH and doing a Docker run or a compose up. But somehow you deploy your app. And so it looks like we did that too. So now, hey, we got hi from the audience. See, and it didn't get deleted and everything's good. And so we've upgraded the app and it's not saying Acme though, is it? Uh-huh. Come on. Has Jenkins ever lied to you? Okay. Well, if this had worked and it had deployed, and it would now say Acme Company, but now it's sort of you end up in this situation of like, well, now that it didn't work, right? How do I go troubleshoot that? Where do I go? Where's my logs? I can go to see the Jenkins job, and it's probably going to say, hey, everything went great. When we clearly know it didn't. See, it was successful. Yeah. Yeah, it could be. Well, someone in the audience goes to it. I am going to the right app, right? Well, I mean, the point is now, like, where did that go? And how do I go debug that now, right? Where are the logs in the container that said, did that actually happen? Okay. Where's the audit log of who did that? Where's all of these things that allow us to monitor and see the state of our application at this point? And so this worked in my favor, I guess. And that this sort of illustrates some of the difficulty in those processes where you're relying on just some of the more traditional methods of deployment using existing tooling. So
cool. So from here, what we figured is once you've gone through your first deployment, you've got an application up and running. The most common experience is like, awesome, we did it. Unfortunately, Bill didn't do it, so he doesn't even get the mission accomplished badge. So he's a sad baby instead, apparently. But there is sort of like pretty quickly as you start to move to containers and you realize, okay, I'm running my database in a container and I'm running my app in a container and I've got this cool little compose file maybe that I stood up on the box. Your logs, all of a sudden, you're going to go to the box and you realize I'm not seeing, anything of what's happening inside these containers. And so pretty quickly, visibility, monitoring, logging start to stand out as the next big challenges that you need to think through as you're moving your apps into containers. Just switch slide. Yeah. So there's a lot of approaches to monitoring and logging in containers. I sort of pulled a couple that are probably the most common I'm seeing right now in deployments. And the big thing is when you move to logging containers, you really need to get a logging agent that can sit basically at the same level as your containers and knows what's going on. There's a lot of good ones out there, but Prometheus is a really popular open source project that is certainly very popular among our user base. And what Prometheus is it's basically made up of an agent running typically on your host, a management service running somewhere, potentially an InfluxDB to give you historical trends, and a front end like Grafana to let you define what you want to see out of all that data. And so you can build and deploy something like this. Similarly for logging, you can use Logstash, Elasticsearch, Kibana, and spin up an Elk stack to drop agents on your host and start pulling logs that are container specific and be able to look at your container logs. So you can build all this out. If you look forward, there's also really good hosted services. Sysdig is one of our sponsors here. We have a ton of users who love Sysdig and run Sysdig in the cloud. Datadog has really good container management or container monitoring services. Similarly, there's hosted logging services. So you can deploy any one of these things, but as you start to think about actually spinning up something like an Elk stack or a Prometheus stack, you get into kind of the underlying challenge, which is that they themselves are complex enough that now you need another compose file. You need actually, if you want to run these in Docker, you're going to need to think about how to deploy InfluxDB or how to deploy an Elasticsearch node or cluster, masters potentially. And we pretty quickly get into looking at defining relatively complex blueprints to deploy applications. The good thing is there's lots of these out there. You can find, good examples of this in catalogs and, lots of blogs about how to build out a Prometheus stack or an Elk stack using containers. But you very quickly realize we're moving beyond the PHP container talking to MySQL. Now we're going to be bringing up multiple services, potentially running on multiple hosts, and all of a sudden, we're not really talking about a simple git push to a single host to deploy an application. We're looking at some need for orchestration, and that's where the drivers for orchestration tend to be scale. They tend to be resiliency. If you start wanting to make the system scalable or something that can handle a single host going down, potentially even availability zones going down, all of a sudden you're driven to need something beyond just Docker run. And the cool thing now is there's lots of options here. There's projects like Kubernetes, like Mesos, like Swarm. There's Joyent has a cool project that's geared around this. There's lots of different things. There's new projects, Nomad from HashiCorp. So there's different types of schedulers and orchestration tools that can allow you to pool together a set of hosts to start treating them as a unit. Of capabilities that are fundamental to this type of technology, such as networking. How do I connect these hosts? Load balancing. How do I start to manage this stuff as it goes out? Service discovery, health checks. How do I monitor the availability of these services? So there's a lot that will immediately grow in complexity as you start to dive into these technologies. And each of them handles it differently. They're all slightly different. They're not that different, actually. I mean, once you've learned one of them, you pretty quickly can understand the differences between these different orchestration systems. And interestingly enough, the underlying component is still just a server and some Docker containers. So fundamentally, even moving between them isn't nearly as prohibitively difficult as you might think at first blush. You can take an application that's written in a compose file and pretty quickly sort of parse it out and figure out how to turn it into Kubernetes service controllers and replication controllers and such. So if you jump to the next slide, Bill, there's a couple sessions today that are going to dive into this in a lot more detail. At 1:20, there's a cluster schedulers and introduces Firmament. So the team from MIT and Cambridge, there's a couple of people here. They're going to talk about this. I think this looks really interesting. I'm looking forward to this session. And then there's a session tomorrow morning on running Kubernetes in production. I think there's a joint section as well this afternoon. So there's a lot of sessions talking about orchestration. This is kind of the big next step. Once you get beyond Docker run, bring up your host, make changes, push things through Docker registry, you're going to start looking at these container schedulers. There's a lot going on in the market that makes it feel like there's only going to be one winner in this space. I'm not a believer in that at all. I see this market being very rich and dynamic. If you've been around technology a long time, schedulers tend to come and go as new inputs and new data gets developed. There's new scheduling inputs that might drive better decisions, whether it's compliance or pricing or new delivery models or serverless computing. It's all sorts of things will drive this. So I think one of the challenges that we run into a lot as we're talking to users is kind of a analysis paralysis. A lot of worry that if I pick the wrong thing, I'm going to be stuck down some path, writing Mesos frameworks and the whole world will be using Kubernetes. I think this is greatly overstated. I really would encourage you to spend almost zero time worrying about this. Find one that you like, move forward, and later you'll be able to switch these relatively easily. Easier and easier over time, I'm sure. Can you jump to the next slide? I want to spend a minute, though, talking about networking because networking tends to be where kind of the rubber hits the road with these containers. As soon as you're spinning up multiple hosts, bringing up multiple containers, you're going to need to implement or have some type of networking. The cool thing is, a year ago, there was a lot of challenge getting networking to work even on containers. A lot of startups and people developing networking to go. These days, networking is more or less out of the box with most of the orchestration and container tools. So you'll get at least some kind of networking out of Swarm and Kubernetes right up when you spin it up. And I think that's, for most people, going to meet their requirements. There are really cool projects like not Prometheus, but Calico, Weave that do more advanced networking capabilities. But by and large, just using Swarm, you're going to get good networking now right out of the box. But what's interesting about the networking layer is as you start thinking about this overlay network and having containers with IPs sitting on a private network, you're going to realize that this layer is where your troubleshooting will spend a lot of time, because if there's a problem here, it's going to really quickly become apparent. So this is also where, in most cases, things like health checks sit. You're going to run your health checks on service availability to say, restart my PHP services when they're down, probably from a networked container somewhere, or maybe multiple network containers monitoring the availability of the service. You're going to run your load balancers to route to a service, and a service may be multiple components that make up, in this case, my 3 PHP servers sitting behind maybe 3 load balancers, all of which are exposing some port on this host and pushing it out to ELB or to F5 or some other thing. So pretty quickly, you're going to have to think of the container network, the ports, and how you expose that out on hosts, and then the real-world network, how you're actually fronting this. Are you registering these ports with a DNS service? Are you putting them into a load balancer? Are you registering them up to an ELB or something? That's where a lot of people start to get stuck and find, this complexity becomes a little bit difficult to understand. So it's easy if you just start thinking about the container network and the container IPs as almost like a separate, like something in the cloud, something that is fully isolated from, the real world, the real network, that still needs to be bridged somehow or another to your host and exposed through ports. I think if you click to the next slide, there's a session today that the team at Uber is giving on overlay networks that goes into this in a ton of depth. Really recommend attending. I think it'll be one of the more interesting sessions, and probably the most important thing that people spend too little time on and comes back to bite them is really understanding how the networking works for their containers. Okay, so demo number 2, we're going to take a look at scheduling. We're going to look at deploying some of those things we talked about a couple minutes ago, Elasticsearch and Logstash, Prometheus, and I think we're going to use, kind of some orchestration to look at how you deploy out all those agents, how you bring up, more complex multi-service stacks, and, how you can make changes to those.
Hopefully things go better this time.
It looks like it's working. Yeah. You got it fixed at least.
Oh, was it the...
Something.
Oh, I have two. All right. So, talking about getting some of the visibility, what we're going to do is basically start deploying stuff that allows us to get that visibility into the environment. So we'll start with deploying Prometheus. This is going to be launching from this compose file. It's made up of several services all working together to deliver a dashboard. We won't watch it all the way start up, but basically what it's doing is it's deploying an agent to every node and then feeding all of the data into a single set of collectors and then presenting that up to you in a dashboard. So we'll launch that, and that'll help us get kind of like the basic stats for the containers and the hosts. And then we want to be able to see our logs because those are always helpful. So we'll deploy Elasticsearch. Again, this is all very similar, and so this is building a multi-node Elasticsearch cluster with, I'll show you, with clients and data nodes, and then master servers, and then it's got a COF for monitoring of the Elasticsearch cluster, which just kind of gives you a nice visibility into what's going on there. We need to be able to move our logs back and around, so we'll deploy Logstash. We'll tell it to use our Elasticsearch clients.
And just to add here, I mean, what Bill's showing is basically under the covers, we're just launching compose files with some additional scheduling capabilities around them. The development of those compose files, the development of those blueprints is really where you're going to spend your time, is sort of looking at or taking from. The example he's using is out of a open source community catalog that we didn't develop these things. They were all developed by people in the Rancher community that just contribute, GoCD or Kibana or Jenkins or whatever it is. But they're good examples of multi-service apps. So if you want to try and get familiar with, what does a compose file look like for MongoDB, it's a great place to go and look at what other people have shared. It's all available in Git. The back end of this catalog is just a Git repo full of these templates that you can go and steal from, look at, learn from. There's two elements to it. There's a if you kind of look at the preview that he was showing earlier, there's a Docker compose file, and then there's a little bit of additional scheduling information that you can put in that goes to like load balancing and other things that are Rancher services. But the whole idea is, as you spin these services up, you're effectively launching not just the containers, but you're setting up the network, you're setting up all of the service discovery so that these things can find each other.
Yeah. And so these are all coming up and basically providing the visibility. And yeah, it looks somewhat easy, but yeah, it's a fairly involved process to build. We'll go to the default environment. I've already got a lot of these up and running. And so we'll take a look at what those end up looking like for us. So here, these are all roughly the same set of services. And we've got Kibana. What we deployed was Logspout, and that's a project by Glider Labs. And basically, it just listens on the Docker socket for events and containers starting, and then it just starts siphoning their logs and routing them off the host to wherever you want them to go. Docker also supports native logging drivers, so when you launch the container, you can tell it to use a driver and send the logs, and you can kind of skip the Logspout step, but I think for demos and illustration purposes, it's kind of neat to have an explicit thing to sort of show what's going on. And so without really doing much, now you get this view of your application logs, and you can see we've got Gluster service running, we've got our Docker app, so we can say, hello, again, ContainerDays, submit that. So that's up and running. Now let's see if we can do a similar demo. Do it from the command line this time. So what I'm doing now is building the Docker container locally. It's pulling down all of its dependencies. It should go pretty quick because it's cached. And then I'll do a Docker push. And this is just manually doing the steps that the CI system was doing earlier. But it's deploying it to a different environment where it's all instrumented. So hopefully we should see the logs pop up and actually get some cool stats and data about it. Okay, so now this is just basically deploying it out to the Rancher environment there. You can see the application is now in an upgrading state. But now we can see also hopefully that we are actually getting some log data. You can see that, yeah, we're getting some orchestrating Docker logs. So if we filter on that, we can see some new log messages coming in. And so here, as containers pop up in the environment, we're now able to capture their logs in a single aggregated place and look around and see what's going on in that environment. And this is really helpful because now you can actually troubleshoot and gain insight without having to go to each container on any number of hosts and do Docker logs and follow. While that's still sometimes useful, being able to see an aggregated view really helps. And so we also deployed Grafana in there, and so now here, basically as things are happening on the host, we get these host stats, we get this dashboard that also gives us some high-level container stats, so we can see sort of what's going on in their state in the environment. And so now, just having this all instrumented, and now as a user of this environment, and you're deploying these containers and your applications to it, you really don't need, you sort of don't need to understand as much the underlying physical infrastructure. You have this ability to go to these aggregated dashboards, collect the information that you need to troubleshoot and make informed decisions.
And this Grafana is based on Prometheus. So you have Prometheus deployed. The Grafana is just the front end to that?
Yep.
Awesome.
Exactly. And did it work this time? Yes. This time it worked. Thank you. Harder than it looks.
All the magic. All the magic. We usually, when we do the meetups every week, we kind of basically just assume that something's going to fail because we demo all this stuff live all the time, and I don't think we've ever had one of these 2 or 3 hour sessions where something hasn't blown up. All right, so last stage here, you've got some orchestration spun up, and I will just, if you go back one slide, we kind of glazed over deploying Kubernetes, deploying Meso, setting up swarms. Those are all relatively complex things. Some of them are much easier than others. The complexity of deploying Kubernetes, it's multiple services, it's etcd, is a lot higher than the complexity of bringing up Swarm. They also have different capabilities, so there's a bit of trade-off in there. Very easy to set up, very easy to get started with, very powerful, lots of capability. All of this is getting easier, though. I will say, if you start to play around with tools, there's a lot easier and easier ways to bring up things. There's also hosted services that will give you Kubernetes out of the box, will give you Swarm clusters. Backspace has a cool one where you just launch Swarm and they give you a whole Swarm. There's lots of cool things out there if you want to try these things before going and setting up your own infrastructure, building out your own Kubernetes stack, and definitely play around with that. Okay, so once you've gotten to that point and you're running now your implementation of containers, a cluster manager, some networking, you've got your monitoring and logging all deployed, you pretty quickly get to dealing with one of two things. If you're actually moving it into production, you're going to start wanting to do some configuration management on these hosts, and as you start to use standardized container images especially, you're going to want to inject configurations into it, and so there's a whole bunch of cool projects around there. We use ContainerDays a lot, but basically ways to start launching concepts like pods in Kubernetes, which is basically a single container coming up, but then multiple other small containers potentially launching at the same time to do some configuration, to maybe modify that initial container, to change it on launch. So we'll talk a little bit about that. Pods, replication controllers become kind of a key component to building more complex applications, especially when you start getting into deploying things that are clustered, like bringing up a Cassandra environment or maybe a RabbitMQ, something that's got multiple components, maybe needs to do some leader election. You can run all these things in containers. They run really well, but you probably need to run them in some kind of an orchestrated environment where you have service discovery or you have a metadata service or you have something for these, something kind of substantial for these services to latch onto and find out about their other services that they need to know about, other containers running the same service. So, as you start to deploy something, we're going to use as an example Gluster, because Gluster is a really cool storage service that can spin up, in the cloud and provide you with block storage for your containers. As an open source project, that's pretty neat. But to bring up a Gluster cluster, you're now talking about, a relatively high level of complexity, a lot of configuration that needs to go into it. You're going to need to have certainly some additional configuration containers going and setting up the masters and the slaves in your ring. And there's a number of other things you'll run into here. Just in general, persistent storage tends to be one of the more challenging elements of containers. It's gotten a lot easier. There's great storage drivers out there that can allow you to mount NFS, can allow you to mount really any existing storage you already have, to EBS and Amazon and other things. So persistent storage, we're not going to talk about it a ton, but it's definitely an area if you want to learn more about. Come by, we'll kind of share with what we know, or ask one of the master people in bucket 3 that raise their hands. But it gets to be relatively complex. You're going to want to sort of think about your architecture as you start to deploy more persistent services. External services is a really common use case where you're deploying this same PHP app, but now you want to run it instead of on a local MySQL or a local Postgres. You want to run it on RDS. But using orchestration, how do you tell the orchestration how to find that RDS, how to incorporate that into your service discovery? So as you use things like console or use the native service discovery that's available in the orchestrators, that will become kind of important to think about, not just containerized services, but traditional services. There's a lot of use cases for this technology where people are deploying it to run pretty traditional Java applications talking to an Oracle backend. And if you're doing that kind of thing, you're probably not going to put the Oracle in the containers, right? But you can put everything else in the containers, and you can really quickly get a lot of the benefits of immutable objects, predictable deployments, even if you don't touch that backend database. But the key is to treat that backend database as an external service, as a component within your service discovery, so that that private network can find the IP of the hosted database or the Oracle environment that I'm talking to. We're not going to be able to go into Vault and secret management in this session, but there's a whole great session coming up later today where Jeff Mitchell from HashiCorp is going to talk about Vault. This is a really great tool for as you start to deal with actually administering production applications and you need to do secret injection. We just did a big meetup last month where we spent about a quarter of it talking about how we support Vault and implementing Vault into your application flows to inject secrets and to manage the workflows. It's pretty complex though. It's sort of definitely level 3 level complexity. There's it's getting it's kind of bringing together a lot of design questions. How do you design your security principles around managing access to the hosts? Access control in general becomes pretty interesting as you start talking about containers, because typically your access controls mostly live at a host level, and now we're talking about things like how do I control access to a specific container? How do I say who can modify a container settings? A lot of these questions are some of the last questions I would say to really be solved. Today, the state of the art is more or less controlling access to environments, or maybe controlling who can deploy from a registry, using things like CI tools to gate who can actually deploy and what approvals have to be in place before you deploy. So I think on a lot of the current state of the art that we see is people deploying through processes that are well defined and then auditing heavily. So auditing all of the stuff, whether it's through just your existing logging or it's more complex logging that you're implementing, is really useful. There's a very good compliance session, I think, today at about noon that Elliot Murphy's going to talk about HIPAA, but I think it's applicable to almost any type of compliance, or if you work at a big company and you know that your biggest concern is how am I going to get this through my security team, my traditional IT team that's not interested in hearing about this, that they've already got all their processes built. This is being solved. I mean, people are running this in probably every major company in the Boston region. They've got containers running somewhere in some department, in some division, either in prod or in dev and test. So people are passing these hurdles, but it's probably something that you don't want to try and take it on without just building up your knowledge, learning what other people are doing. I think coming to events like this is a great start. If you jump to the next slide, Bill, I want to just, as we jump into, we're going to demo next kind of how to deploy these type of, we're going to use Gluster as an example, but these more complex applications that rely on replication controllers and pods and multiple services working together. And to give an idea, when we deploy Gluster, as we bring it up on sort of multiple hosts, each host, we're not just deploying the Gluster container, we're actually going to be deploying 3 or 4 containers, all of which are basically slaves to this Gluster process, doing some configuration on it or setting up some component of the file system. Bill's going to walk through this in a little more depth and explain how it works and demo it. But just this is where as you kind of work and take more complex applications, there's great tools out there in the community. There's a lot of these problems have been solved, but it's probably worth, especially if you're if you're still kind of moving from level 2 to level 3, finding one of the consultants in the region that knows this stuff cold. There are some amazing consultants here in Boston and New York that have implemented this at all sorts of companies. We know a ton of them. They tend to be people we meet at these conferences, who speak at these conferences. They can help you enormously with when you get to this sort of level 3, understanding the blueprints, understanding how to implement more complex configuration management and deploying more complex applications. So, Bill, you want to take it away?
Yeah. So, yeah, as Shannon sort of pointed out, that there's when you deploy these applications, they're clustered systems. So they actually sort of need to know about each other. And so in order to achieve that, you sort of have this requirement now of either knowing everything up front, which typically in configuration management systems was the case, or you use the newer tools around service discovery that have made a lot of this a lot simpler. And then when you're deploying these apps, you don't just the best practice is to run a single process per container, and that's it's involved. So basically, you end up having to define the roles of what's going to happen in the system. So when you really bring something up, you have to understand what's really happening. And so here with Gluster, you're basically laying down a common file system. It's just a container as well, but you're saying here are the paths that everything's going to be able to see. And then when the process comes up, that's great, but then how does it know it's not part of a cluster at that point? So we need peer detection. So we need to have a container that's sole responsibility is just finding peers somehow in the environment. And so it queries service discovery, it does the pings, and adds them to the cluster as itself. And then in the case of Gluster, you were creating a storage volume. And so we're creating a replicated volume. So we need to make sure a certain number of hosts are available, and we need to make sure that the command only runs once, and it's only run from a single source, because you run it once and it gets created, and then you don't want all of the containers to do that. So there's a lot of coordination that needs to happen in these systems as you're trying to bring them up and bootstrap them. And so we've got a demo. I have one deployed, but I'll go through deploying one of them. And I'll sort of walk through the compose file as well. So here what we're looking at is a definition of the larger. Sure. Cool. All right, so we've got a definition of all of these individual services. We've got the server, we've got the daemon, we've got a volume create container, and then here the actual data container. There's big warnings on don't move that one, otherwise you could lose all your data. It's bad for clustered systems, storage systems in particular. But here what we're defining is there's that data container, and you can see every one of these other services is doing a volumes from. And in terms of Docker, what that'll do is it'll take the volumes from that container and make them available at the path inside your other container, which is pretty neat, because then you can kind of share information between these containers, and you start getting the ability to cooperate as things are deployed. And so then the other thing we're doing here is we have a network mode. So typically, a lot of these systems, each one of these individual containers don't need their own network interface. So a lot of times what we do is define and have them all share a network space, namespace, so that they're just one network interface. And so it's really acting like a little mini server at this point, is what we're essentially building. Kubernetes does this by default. So it came from Google as a best practice, so it's got to be good. Yeah, and so then each one of these will basically just perform the roles that we described in the picture there. There's some basic scheduling rules here that say, spread it out, because you don't want all the data to land on a single node. So when you launch that, things start happening. But while it's doing that, we'll just kind of go, I've deployed it earlier. And so you can see it's just a lot of services. But here we can look, so we'll just kind of follow Gluster Server 1. So when this container came up, we can see the first thing to come up is this data layer. And so it came up, and it did essentially nothing, right? It was bidden true as a command. It comes up. Its whole function is just to provide volumes. So then once that came up, then we've got this, the daemon that came up. And it came up and did its thing, and everything was great. Then you have the container that came up and did all of the peer probes. So this is the one that did all the detection. It was querying service discovery. It knew that eventually there's going to be 3 of these nodes. It waited for that, and then it just started saying, okay, I'm here, and then peer probed, and then everything was able to connect up. And then here, following this, it was waiting for all the peers because it also knew that there's supposed to be 3 containers in the service to come up, and then it was basically waiting for that to happen, and then when it did, it made sure that their Gluster all knew about it, and then once it was aware that Gluster itself knew that the 3 nodes were available, it created the volume. But a cool thing to note is that was container service number 1. Container service number 2 is the same container, and it waited for the services to come up, but what happened behind the scenes was simple leader election. And so basically container 1 knew that it was first, and so it actually handled the volume creation for us. And the others did not.
So we're running out of time. We've just got a couple more minutes, and I just want to go through the last couple comments. But hopefully that gives you some idea of the sort of breadth of what we're talking about here, and we're going to cover today. There's a lot of depth in this topic of looking at these different types of applications that you can containerize, and I think it's one of the things that's great year 3 of the Docker movement, I suppose, is that the ecosystem is getting really rich. There's a ton of companies, there's a ton of projects that are out here. You can see all the sponsors that are making it easier, that are solving point problems, solving entire management problems. So definitely, as you get going with these things, feel like it's a playground to go and explore, because almost everything is free. I mean, the vast majority of tools that are out there are open source. They're free. The biggest effort going on is into big open source free projects, right? Docker, Kubernetes, Mesos. These are all open source projects. So, you can get very comfortable, very familiar, very quickly. And as you scale, as you grow, there's companies behind pretty much everything out there that would be more than happy to support you and provide services. So, I think you get kind of the best of both worlds these days. I mean, you compare this to, virtual machines when they came along. It wasn't until like 3 years later that we got the first sort of open source Zen and the first open source virtual machine. This entire movement is starting in open source, and everything's open source. And almost everything is not open core, not like, well, some of the capabilities are open source, but if you want the really cool stuff, you've got to buy it. Almost everything is really open source, and that by itself is pretty amazing. I think it's one of the reasons the whole space has grown so fast. My last comment would just be don't get caught up in too much analysis paralysis on this stuff. I see it every day. People doing enormous matrices trying to decide between, I don't know, Sysdig and Datadog or something. I mean, these are great tools. They're all good tools. You're not going to go wrong picking one of these things. The biggest thing you can do is spend too much time and feel like you're kind of you're choosing between getting on the Titanic and getting on whatever other boat was going to New York that day. It's not really like that. So wouldn't stress too much. You're probably going to be fine whichever way you go. If you click the next thought, I'd certainly, my last point would just be certainly invite anyone who's interested in learning more, diving in. We run these meetups every month. They're all just like this. They're all very hands-on. The only difference is we're usually begging people to stop asking questions, because it's just kind of a question flow. If everyone asks questions the whole time, we go for hours. But we record everything. We put them up on YouTube. Anyone's welcome to watch them, learn about them. But they go from getting comfortable with Kubernetes to learning all about Vault and Sysdig and learning how to build these catalog templates that we were showing a couple minutes ago. All this stuff is out there. It's very easy. So welcome. Excited to be here. So excited to see so many people here learning about containers. Thank you again to all the organizers who worked so hard and donated so much time to put this together. an awesome success, and this venue is amazing. So anyways, thank you very much. Come say hi later.